Hey everyone, thanks for joining us for the final day of the Midwest Oracle User Group and the Chicago Oracle User Group virtual conference. We do this annually, typically in Chicago, but last year and this year are virtual, so we do hope to see you on site next year at Oracle Chicago. Today's session is sponsored by Viscosity North America. If you're not familiar with me, my name is Monica Lee. I'm the marketing director at Viscosity North America, but I'm also the conference chair for the Midwest Oracle User Group. So I do hope to see you guys in person next year. A few rules, or house rules, I guess I should say, before we get started. This is a live webinar, so please feel free to take advantage of your time with today's speaker, Marcos. You can ask him questions in the questions portion of GoToWebinar. You should be able to see that right now, somewhere around the bottom right-hand side of your screen. He'll get to questions as he can, most likely at the close of today's session, but feel free to just start submitting questions as you think of them. Other than that, we will have a follow-up email to you. It might be by end of day and it might be Monday, just depending on how long it takes for today's recording to render. So look for an email from my colleague, Katie Barnes. Feel free to ask her anything you need about Viscosity, about MOOG or COUG, or today's session. She can help you out quickly and she'll get you a slide deck as well. So with that, I'm going to hand it over to Rich, who is the president of the Midwest Oracle User Group.
Thank you, Monica, and thanks for all your work on this conference. For those of you that have been with us the whole week, great to have you again. If you haven't been here the whole week, you can go to recordings of past presentations. On Monday, we had Wooly Hardy talking about 21C and all things that are coming out new in Oracle database development. On Tuesday, we had Nitin Vengolekar, who talked about the COVID-19 testing and vaccination system that Oracle built, and it's a real world study of that and how they built that with Apex and some of the actual stack that was built. On Wednesday, we had Machine Learning 101 and on robotic process automation. On Thursday, we had what's new with Oracle's Chicago Innovation Lab. So Oracle's Innovation Lab right here in Chicago. And that was with Virchin Kaplan-Oglu. And the next speaker you'll hear today, Marcos Arancibia. But before we do that, we want to have our sponsor take a chance to show us a few things. So I want to introduce Jason Wapaki, who is our Viscosity sponsor today. Jason, first of all, I want to thank you very much for coming and sponsoring the MOUG virtually. And with that, I'll hand it over to Jason.
Absolutely. Thank you so much, Rich, for the presentation. We're really excited to be sponsoring the conference this week. As everyone trickles in, just wanted to first thank you guys for joining the session. Before I pass it back to Rich to introduce our speaker, Marcos Arancibia from Oracle, who will be leading today's presentation. My name is Jason Wapaki. I am the Director of Oracle Technology and Sales at Viscosity North America. Really excited to kick the session off with an intro on Viscosity, our company, and our areas of expertise for those of you that may want to have future conversations offline, more tailored to your needs. We can certainly schedule a time with one of our ACE directors. A common trend in the tech space, especially during the last couple of years during the pandemic, a lot of Oracle customers are becoming more dependent on professional services teams to advise and to help their companies adapt and make better technology decisions as technology continues to evolve, more options or versions become available or even obsolete. So at Viscosity, we're partnered with Oracle. We're an Oracle Platinum partner. We're a team that's really built to implement the technology, to provide best practices, and most importantly, ensure that all of you guys have the proper training in place internally to keep the lights on. So we really have three areas of excellence that we focus on. The bulk of our business is really on database, data integration, zero downtime migrations, upgrades to the latest versions, including 19C, and performance tuning at the database level. We have an applications practice. We do a lot of Apex development, EPM, ERP, custom application development, and we also have an infrastructure and a hardware practice, and that includes Oracle's public cloud offerings, bare metal, and engineered systems. But as you can tell, we do pretty much everything when it comes to Oracle, but these are just the broad areas that we focus on. And the point I really want to drive home is at Viscosity, we like to help people. We like to train people. We enjoy helping you guys as developers, DBAs, IT managers succeed at your job. And there's nothing better than having an Oracle ACE director at your fingertips that you can reach out to at any given time if a question or need arises. True, genuine relationships. Last but not least, we've also authored several books. I think we're up to 23 books now on Oracle's latest and greatest, and we want to meet people like the audience in attendance today. So for those of you that are interested in meeting with us, you can send myself an email. I can drop my email in the chat. You can email hello@viscosityna.com or email katie.barnes@viscosityna.com as well. We would be more than happy to set up a time to connect. And we sponsor many free events for you and your teams to check out. And you can register for these events at viscosityna.com/event. So without further ado, I'm going to go ahead and pass it off to Rich to introduce our speaker today, Marcos Arancibia.
All right, guys. I think this is a treat because although there's a lot of people that speak on machine learning, few go into greater depth. Marcos Arancibia is the Senior Principal Product Manager of Machine Learning. And his talk today is, you've got a model, now what? How do we take that next step with machine learning with one of Oracle's top machine learning gurus? He works within product management. He develops strategy, roadmap prioritization, product positioning, and product evangelization. He works closely with the engineering team to define the product roadmap, where it's going for machine learning and big data in the cloud. Before joining Oracle, he was 9 years ago, he was at SAS Institute for 13 years where he did data mining. So he's been doing this for decades. He's an expert on deep learning and passionate about machine learning. Marcos, take it away. Great to have you.
Thank you very much. Thank you. Thank you very much. And hope you guys can see my screen, right? So
We can see it.
excellent. So today what I wanted to talk about is really focused on machine learning. So once you have a machine learning model, what to do with it, right? I'm going to be giving a brief introduction then on Oracle Machine Learning. Just a quick product overview. I know Rich did part of that on Wednesday. So if you guys did not watch that, you're going to have a quick opportunity to see just a quick brief intro on that. But then I want to touch on the point on how to deploy, right, these algorithms. Once you build a model, once you have the team working on these algorithms, how do you deploy them? How do you make them a reality, right? That's usually the point that is probably most difficult for many companies. I mean, most of the projects that fail are because there's not the right place, the right timing, the right speed on which to deploy, right, these algorithms. So let's take a look at that. Then I'm going to talk about model building with one language and deploying with a different one. And I'll explain why, right? Why that is interesting. And then also the new AutoML UI that we have available in OML. Also how to do the model inference, right? And then use our APIs. We have also a special service that takes care of that. So we'll see all of those things. We'll see some demos as well. And at the end, I'm going to talk a little bit about what the OML services does, right, to help you with that. So just a quick, brief overview of what OML is. So Oracle Machine Learning is basically a component of the Oracle database, right? For more than a decade now, the Oracle Advanced Analytics, right, we used to be called, but now the Oracle Machine Learning are the components for machine learning that are embedded inside the Oracle database of any Oracle database class, right? So right now we are inside any Oracle database that you have available. We have also that component inside the Autonomous database, and we have even in the free tier. So you can actually use our algorithms and our capabilities even on the free tier directly, right, without any problems. We have several components though, and these have to do with model deployment, model building, model management, right, prediction details, R and Python languages. notebooks now, we have different workspace and projects. So there's a lot of different concepts, but the idea is the data is in the database, you have tables, and now you can run machine learning against those data, right? Against that data, independently of the volume of data. Okay. So the idea for us was always to make it automated, right? To make it scalable and to make it production ready, right? So I see one question is whether it's available in the database express version. That's a good question. I think it is, but I would have to double check that. I think we were trying to get it to the database express. I'm not sure that was something we were able to do, but thank you for the question. That's something that I have to come back to you guys with. So the following then that process, right, of all these different components, then in the data management space, we have the autonomous database, right, as I mentioned before. And the idea is you have database, you have data lake, access, integration for data preparation, exploration, all of those different things. And in the Oracle Database Cloud, you have not only the autonomous database, right, but you also have database cloud service, you have Exadata cloud service. So every time you have a database there, you can have that running. And that includes also a Docker with Oracle database running inside it in our Oracle Cloud, for example, right? So those are all valid options. So basically the components that we have then for OML are, on the left-hand side, you see we have some interfaces, right? So these interfaces are basically the popular languages, right, that the data scientists normally use. So we have SQL, of course, and we have PL SQL components that are running there, and that has been around for 10 years now. We added R. So by the time I joined the team, the product management team, almost 8 years or 9 years ago, we started promoting R and using R language to execute and run all the components, right, and all the machine learning. And then maybe 3 or 4 years ago, we started seeing a trend in Python. So because Python started trending up and up very strongly on the data science community, we then switched priorities into Python to the point where we pushed Oracle Machine Learning for Python in Autonomous just the beginning of the year. And Oracle Machine Learning for Python is going to be available with on-premise database 21. And after that happens, we're going to have it backported to 19C. So on-premise, whenever database 21C comes out, Oracle Machine Learning for Python is going to be embedded there, included. So easy installation, easy setup. And then once that is out, I imagine a few months after, we're going to have a backported version for 19C customers, so that you're going to be able to install it also on your on-premise, on your database cloud service, on your Exadata cloud service, if you want to, at that point, okay? On the right-hand side, we have some interfaces, right? So we created the Oracle Machine Learning Notebooks that now, probably a couple of years ago, with the Autonomous, right? So with the Autonomous database, you immediately have for free access to the Oracle Machine Learning Notebooks. And they are basically a Zeppelin-based interface, right? So they are notebooks-based, a Zeppelin-based interface for you to type your code and then get the results and then create a nicer report out of your process, right? That also supports Python, right? So we added the interpreter for Python as soon as we released the Oracle Machine Learning for Python in Autonomous, right? We have the Oracle Data Miner. That's still a UI that we use on on-premise deployments for SQL Developer, right? So if you have a SQL Developer desktop, then you can actually have a plugin for Oracle Data Mining, and that allows you to create workflows that write SQL behind the scenes, but you just drag and drop icons right around. And that's an excellent tool to even allow you to, or teach you all of the SQL code that you would use on data preparation and then on some of the model execution. We have Oracle Machine Learning for Spark as well. That is a component that our team developed for the Big Data Service, and that the latest version has been just made GA, right? General availability last week with a new Big Data Service from Oracle that is based on Oracle's distribution of Hadoop. So that's all Sparking brand new. We added that OML for Spark, now supporting Spark 3.0, right, or 3.0 something. Then at the bottom, we have the two newest components, the Oracle Machine Learning AutoML UI, that I'm going to show you guys a quick demo, and the Oracle Machine Learning Services. So the AutoML UI basically allows you to build algorithms and build models for, it evaluates all of these algorithms at once and then allows you to select the best model for your case without having to type code, right? And once that is built and that is ready to go, you can then deploy that model. So I'm going to be talking about that deployment. And OML Services is the place where you deploy the models, right? OML Services is the environment that allows you to deploy models, score models really fast, right? That we're talking sub-second, right? Executions, and sometimes lower than 100 milliseconds, right? So that's exactly a place for you to score small things, mini batches of data that you need to score very fast. Okay. So how does that work today? So today, this is the way that the components work. So you have on the left-hand side the different IDEs, right? That's what customers are using as interfaces. So you have OML Notebooks, then you have Python client, maybe that PyCharm or Jupyter Notebooks. So OML for Pi, when it becomes available on the Oracle database on-premise, like you can see that connection, we will have an OML for Pi client. So you would be able to take that OML for Pi client and install it anywhere you want, including on your own components, right? Jupyter or you know, on the PyCharm, right? And then with that, you can connect to the autonomous, to the Oracle database on-premise, right? Initially. Later on, after that comes out, we also have planned a Python client for Autonomous. So today, in Autonomous, you have to use our interface, right? You have to use the OML notebooks with our Python interpreter. What we are expecting to do is then after we launch the DB21C and we backport it to 19C, eventually between those dates, we're going to have an OML for Pi client for Autonomous database so that you can then, instead of using our notebooks, if you prefer, you can then plug them into a Jupyter notebook of your own choosing, and then you can still use Autonomous database and then OML through that OML for Pi. Okay. SQL Developer and SQL Developer Plus are things that today you can connect, right, to both environments. You cannot use Oracle Data Miner with Autonomous database though. That's the only exception, but you can type in all the code, right? And then REST API clients like Postman, like other API clients that you might choose and to use, they are all available for you to use with our REST components, right? Including Oracle Machine Learning for Python REST APIs in Autonomous and OML services. And our customers, I would say 99.9% of my customers that use they use RStudio in one way or another, right? So RStudio server, our Studio client, our client, those are definitely supported and much used, right, by our customers. And the SQL Developer with Oracle Data Miner, as I mentioned before, it's available to connect to on-premise and on OCI Cloud, the database cloud service and Exadata cloud service, for example, right, to build machine learning workflows. So for 21C, we have a few new things, right? We have an XGBoost algorithm that has been probably the most asked algorithm ever for the last 5 years, right? That customers have been asking for. It's very popular. It's very powerful. So out of the gate, it does very interesting models, right? So ensembles, right, of trees. So that's going to be available on 21C. That's going to run for classification and for regression. And we're going to have it available in 21C. It's at the moment, it's not going to be backported at 19, but we have been hearing some customers ask for it. So I'm not sure how that is going to evolve, right? But for now, the intention is to leave it at 21C. Okay. So also the MSET, the famous multivariate state estimation technique for anomaly detection, that's something that is coming as well on the 21C. For neural networks, we have a few additional capabilities. An Adam solver. Today, we only use the LBFGS solver. So the Adam solver is going to be just another option that's probably going to require less memory to run. And then a ReLU activation function, that's going to be an important addition as well to the capabilities. And also we have an enhanced prediction details. Today we have a lot of good prediction details for every prediction that our algorithms do. But we're going to work on getting even better prediction details quality, especially the output, the type of output that we can get, right? So that's for the new things. In terms of algorithms themselves, I just wanted to leave the list here. I mean, you guys can take a look at any time. But I wanted to keep it over here so I can, share the slides later on and you guys can take a look, right? But it is a very complete list. We have, again, and that's why we have some Python and some R code to support some open source algorithms that customers still would like to test and use and compare and contrast, right, with all these different things that we can do. The good thing is we support text, right? So all of these algorithms can do text mining inside them as well. So even if you're running a logistic regression, if you're running a random forest, we support automatically all the comments that the customer might have said, and we create a bag of words, and then we can input that process in there, for example, right, in an automatic way. Or we can then take things like themes instead of just a bag of words. Get a little smarter and get some themes of the topics that the customer was speaking about. So all of those things are available for you. So model deployment. So now what we're going to do is we're going to take and assume I'm going to show you some model building and then some model scoring, right? Scoring is what normally data scientists call as inference, right? So that is something that you can see normally people talking about, but I'm going to be referring to very much here at scoring at sometimes, right? But inference is also another word for that. So let's take a look at code here, right? So on the left-hand side, I'm running the following code, and by the way, this code runs on any database, right? And any autonomous database as well, including the always free, but any database that you might have. If you take this code, you're going to see that you can actually build a model, right? Build an algorithm, because I'm building the model using the sample schema SH supplementary demographics, right? So that's a table that is always there. It's on the sample data on any Oracle database. So if you run this code exactly like this, you're going to see that on the left-hand side, I'm building a model, right? So I am saying, hey, please build a decision tree, right? And you can see the decision tree right here, right? So you can ask for a specific algorithm. I'm building a decision tree here. And then this is a name, the name that the model is going to have. So that's why I'm dropping. If that model exists before, I'm dropping it, right? Because I need to keep the name. And keeping that name here, I'm running the decision tree for a classification. My input is select star from supplementary demographics. I have a customer ID there, and then the target. So what I'm trying to predict is the affinity card, right? Is whether or not a customer would buy an affinity card, right? Or would accept an offer for an affinity card. So that's okay. On the right-hand side, what I'm doing then is after that model was built, that model is stored in the database, right? The database has that repository, a special repository, where that model is built there. To score that model or to run an inference, all I need is the single select. So I do a select customer ID, right? Prediction probability. So prediction underscore probability means I'm going to pass you a model name that I'm going to get the probability for. That's the model name. So you see the same model name here and here, right? So I built the model name with that name. Now I'm going to run that prediction affinity decision tree 1, which means what is the probability I'm predicting? Because I'm trying to predict whether or not the customer acquired that, I got to pass a number 1, which means he did acquire. So I need a probability of 1, right? Using everything, all the columns, as probability from supplementary demographics. In your normal use case, you will take new data, right? A new data coming in that has the same layout, right? With the same kind of columns there. And then maybe I want to filter where probability is more than 50%, and then order by probability, for example, right? So all this means is you're building a model with PL SQL on the left-hand side, and on the right-hand side, you're scoring or you're running an inference, right? So as long as you use the same model name, and that's important, you can then run that prediction with SQL or with Python, right? Right now, and with R as well, right? Coming up, which is what we have coming up. But with both languages, in this case, you would be able to build a model and then run that inference right there, okay? As an example, then inside our machine learning notebooks, right? So the OML notebooks basically is our collaborative UI, right? You have access to it immediately when you have an autonomous database. So if you have an autonomous database, even if it's the always free account, okay, you have access to OML notebooks. In there, we have around 50 something templates already pre-built for you guys with all the different models and functions in SQL and Python. Basically, the idea here is this UI supports SQL, PL SQL, and Python today, right? And we're working for the R, right? We're working on the R interpreter for hopefully later this year, maybe early next year, but I can't tell you guys an exact date, but we're working on R as well so that we would have the entire family of languages capabilities here. So the coolest thing with the OML notebooks is that you start writing markdown code, like you see on the left-hand side, those comments. So you can make the comments nice. You can then run Python, straight Python code. You can get matplotlib plots like you're seeing here. And then you can run on the right-hand side, instead of using the matplotlib, I'm using the OML graphics. So I'm using a histogram that the Oracle Machine Learning is building. In this case, what happens is OML is sending the code to the database. The database is only computing the heights of those bars, right? And then when it comes back to you, all I need is like those 10 values, right? The heights of the bars, and then the labels, and then the labels on the Y and the X, and you get your plot immediately back. So it doesn't matter if you're plotting that for a small 100,000 record data set or to a billion record data set, right? The database is building and computing those behind the scenes, so it can do it very fast. So this is, again, OML notebooks included with Autonomous, so it's provisioned automatically with your Autonomous. If you go and get your free Autonomous account, you get it immediately. You can start playing with it right away. Okay. All right. So model deploying and scoring with OML. So now we're going to be building the models with PL SQL, but the inference scoring is going to be done with Python. Okay. So now it's an interesting thing because that's a capability that we have, right? And how does that exactly work? So it works with the Oracle Machine Learning for Python and R, but specifically for Python on Autonomous, right? But basically, we use the Oracle database as our HPC environment, right? That's our high performance computing environment. So we do explore, transform data, analyze data. The database can do that all, right? Very fast. So you can use the in database parallelized algorithms, all of that capability, by just using our interfaces from within Python and from within R, right? All of those functions are doing is translating. So we translate your code from R or from Python. Whenever it's using a transparency layer, we translate that code and then we use the proper SQL behind the scenes. Okay. So say you say I need an average, so you put AVG in Python or in R. What we're doing is behind the scenes we take that and convert that into a SQL call to an average of that column, right? And then we bring back the result. So you're never moving lots and lots and lots of data, right? You only move lots and lots of data if you wanted to. So if you build a model that's 1 million records, you want to bring that all to memory to do something locally, that's a possibility, right? So we give you that flexibility. And then we allow you to run R and Python functions directly with the Oracle database. So you can push that capability. The Oracle database can start up those Python sessions like you can see in the chart here. And then we can run those things for you so that you choose to use an open source code, right, that you would like to deploy and run, you can. And then I'm going to show you guys later on an example. And then all of those, and then in the we have also an automated machine learning capability that we mentioned before that allows you to then say build the best model possible out of all the OML models for my problem, right? And then that process is going to kick in, is going to run several algorithms behind the scenes, and then it's going to come back to you with the best one, right? Another thing that we do is the algorithm selection. So you're going to run algorithm selection, feature selection, and we're going to be talking more about that in details, right? And then there's an MLX, which is the model explainability. And that is also new. And then it runs, so both of those, AutoML and MLX, for now run only from Python, okay? So the MLX allows you to, it's a model agnostic way of looking at the feature importance. So if I build a model that like a neural networks, you don't really know, there's no easy way to say what's the variable importance because of all of the transformations that happen inside. So this guy allows you to run variations. It sends perturbations on the inputs, and then it evaluates the output, and that says, you know, this one is the one that have the most influence on the output. And it treats that as a black box, right? It treats everything as a black box, does some variations in the input, and then checks what is the impact on the output, right? So it can give you a more real life experience, right, on that. So with all that capability then, it is pretty interesting. So what happens here is, again, on the left-hand side, I have the exact same code I had before, right? I'm doing the same prediction, same model using a decision tree with the same name, right? Pred affinity DT. But look at that. Notice that on the right now, this is Python, okay? So on the autonomous database, I'm doing import OML, which is loading that package, right? The Oracle Machine Learning package for Python. And then I'm going to say synchronize the table, right? So I'm giving it a scoring data frame. That's a proxy object. So I'm creating a new proxy object that points to that table. So with the OML sync, I'm not pulling data over, okay? I'm just creating a proxy object to point to that table. And then I'm loading that now. I'm building that model, so I'm going to load that model that already exists. So instead of using oml.svm, for example, to build a model, right? And in this case will be, in this case, I would have to switch it to a decision tree, right? So I'll have to use DT here and then DT on the name over here, right? But I can load a pre-built model, right, from that I built on the database, and then I can use it for scoring immediately, right? So I will do model, which is this proxy object to the model now, dot predict proba to predict probabilities, and then I bring my proxy for the data frame, right, the scoring data frame that I have here, which is that table, and then I will give it supplemental columns saying, you know, let me just pass you customer ID as well, just because it is always useful, right? When you do inference, you really want to get customer ID and the probability, right? It is possible to guess just the probability, but then you might get this thing out of sync, right? Because if you got thousands of probabilities just on a one vector, you don't know exactly which one is which when you're going to join that against another table without having an index. Sometimes might be complicated, right? So it is always a best practice to use something like this, right? So I'm building a model with SQL, and then I'm scoring it with Python. And we got to make sure that the opposite is also true, right? So in here, and that's the coolest part, I think, you can have your data scientist building a model with Python. So now I'm importing pandas, importing OML, do a data sync, right, with my input data, doing a test and train data. So I'm splitting that into 60 and 40% for training and for testing purposes. And then I'm creating the X and the Y, which is a requirement by Python, right, where I have all of the attributes that are input attributes and the target in a separate vector. So I do all that, but there's no data transmission here. At this point, all I'm doing is I'm creating views of a view, okay? So it's all a proxy of different views. I'm never duplicating your data. I'm not creating anything. I'm not bringing anything into Python's memory. It's just a bunch of pointers, right? So at this point, I'm going to say the settings for that machine learning random forest, right? So I'm telling it how, you know, what is the depth, how many trees I want to use. And then I'm going to do a fit. When I do the fit, that's the tricky part or the important part. I use the train X and the train Y. I do case ID, but then I say model underscore name. If you don't do that, the model, when you build into Python, it's temporary, right? So you will not know the name of that model inside the database because it's going to get an automatic name, right? So when you say model name equals that, then now it's the same as if I was building the model with PL SQL, right? You get a specific name, and now it's easy to call. So again, the code for model scoring is going to be the absolute same. The only difference here is now I'm using prediction affinity RF, which is the random forest that I use on the left-hand side, right? So I use a random forest, register the model with that name. I get that same exact model here, and I do a prediction of probability of 1, and there you go. So you got the model. So why this is interesting? Because you can have your data scientists still use Python, which is probably their preferred language many times, to build models, but your application can be calling that model using SQL, right? Your final application, your production applications are going to be calling always a SQL call, right? A JDBC call, very fast call against your database. You need that scoring done immediately, right? You can't wait for Python and to think about anything. This is a SQL call, immediate call, right? So that's definitely an advantage here, right? So then we go to OML Automl UI, right? So as I was mentioning before, AutoML, without the UI part, AutoML is going to come with OML for Pi. So inside OML for Pi today, you have AutoML that you can just call and run with that command, and that module is going to go to the on-premise as well. So database 21C is going to launch, OML for Pi is going to be there, and AutoML is going to be there as well. Okay. Now that is for coding. So if you're coding in AutoML in Python, if you're coding in Python, you can use AutoML functions, right? Now, AutoML UI, it's just a little bit different. So what that does is tries to simplify everything. If you have access to OML Notebooks with Autonomous, so any Autonomous has, again, even the free one, the always free one, then you can have access to this. So in here, all you need is you put some training data in. We're going to run an automatic algorithm selection for you, where we're going to identify the in-database models, right? Out of the in-database algorithms that we have, which ones are the best, right? The higher capabilities, right, for you. And then we're going to do a better job than the full exhaustive search, right? We have very specific parameters that we look for. Then we're going to do an adaptive sampling. So we're going to check whether you actually need to do an adaptive sampling. Maybe we need to adjust, the proportions, right, of the target and the in 0, 1s or whatever it's needed to make sure that you get the best performance out of these models, right? And then you get out of feature selection after that. So the feature selection, what it's going to do is going to say, okay, I now decided which ones are the best models for this problem. Now let me see if taking a few of these features out, right, of these different models can actually make my model even better, right? So we're going to do a full-scale selection of those features, see which ones are actually the more important ones to leave in, and then discard anything that is garbage, right? That doesn't bring anything, any information into your model, right? And then finally, we do a model tuning. So at that point, we're saying, okay, now that we decided all of these processes, at the end, with a final tuning, let me see if 10 decision trees is better for this random forest, or 30, or 50, or 100. So there's a space, right, on which we can search for that capability of the model and fine-tune that model, right? Same thing with neural networks and the different number of layers and things along those lines, right? So all of that, then it gives me the final machine learning model, right? And in addition to that, we added that capability that I was talking about before, the model explainability, the feature prediction impact. So inside that same UI, you will see the use of that to rank the features, right, from the best to the worst, right? So for example, then this is a screenshot of exactly that project, right, or that process. So when you go here now in the Oracle Machine Learning notebooks, right, it used to be that you only had notebooks, but now you have AutoML here, and actually there is a new models icon for the models component here. But then this is basically showing you that, as an example, this is an experiment that I was running, right, for customer propensity to buy insurance. So I was using the same data set again, right? And we were running, you can see the different models and different algorithms that were tested. So we can test and select. The default is 5. Show the top 5. You can go all the way to 8 and show the 8 different algorithms that we can test. And then the idea is that it's completely automated. So all you do is just show the input, tell it what is your target, and just let it run. And then here on the right, you can see the prediction impact. So you can see what are the columns or the attributes, right, that were found the most important to determine whether a customer is going to buy insurance or not, right? So these guys are in order, right, of importance. And here on the right-hand side, you see that the list of the things that it ran, right? So it's going to go and show you a checkbox during that process. So whenever it's running each step, it's going to show you that process as well. Okay. So the idea is minimum user input and to take advantage of that. And the OML models. So when you go into the models menu, then this is where you're going to see a list of existing models, so user models, and the model deployments. So we're going to talk about this, but you can, from a user model, you can click a button here on a list of these models and click on deploy model, and you can say, I would like to take that model that we just saw, right? That for example, I built with PL SQL, or you built with AutoML, and I want to deploy that model to the REST service. So now I'm going to say, give it a name, give it a URI, a version, and then put it a namespace and then say whether it's shared or not. So I want everyone to see that model, or I want only my user, right, to be able to use that model. And with that process, I can then deploy that model. Okay. So let's take a look at a quick demo then. So let's see a quick demo on these how that process looks like. Okay. All right. So I have then model scoring via AutoML UI experiment. So here is assuming I have an experiment. One of those was increase purchase prediction, right? Insurance purchase prediction. And then I go into my model. So here are my models, and this is the random forest. So I can actually create a notebook. So that is one way for me to deploy that model. I call it a my prediction notebook. I create that notebook now, right? And then I can go into notebooks, right? And if I go into my notebooks now, there's my automatically created notebook. So the AutoML UI built a notebook for me that is completely automated in Python, and I have that. So I have all the code, import OML. It shows me all the columns that it was created, right? So it shows me all the data that was originally used to build that model, right? And then if I scroll down, is then going to create the train data. So the X and the Y that again you need for Python, right? So the X is everything and Y is only the target. It's going to then build the random forest, but you can see that it's building it using all of the settings, right, that were identified by AutoML to be important. And now that it builds the model, it just is a dot fit. So I have the model there. So what I'm doing is I'm rebuilding a new model right now out of the AutoML, the one that it was the best that I chose. It builds the notebook for you. So now you can register that model and start scoring with it in SQL. Or I can score immediately here automatically from, from what I saw before. So I can do a score, right? And I can see that prediction immediately, right? So prediction and the probability. So the idea here is that you can then see that capability, right? And then finally, check the accuracy of the model if you wanted to. We automatically generate all of this code. So all you have to do is just click a button and run everything, okay? When you're done, okay? So that's the easy part. Let's say the easy button, right? Now on when it does auto generation of notebooks, right? We can then make changes and register a new OML model. So let's take a look at that process, right? My animations are, apologies here. So now let's go to the deployment, right? So AutoML model deployments, and then I'm going to see the leaderboard again. And now I'm going to deploy the model, right? So before I created a new notebook, now I'm deploying that model. So I'm giving it a new name, and then I'm giving it the URI. So the URI has to be like a unique REST, name, right? That the model is going to have. I give it a version, call it the namespace, and I say, okay, and now that model is deployed. But what does that mean? That means that that model now has been shipped to OML services, okay? The second way I can do deployment from the models directly as well. So after I've spent the whole day building different models, I can come here to the models menu, click on one of them, and click on deploy as well, right? So from here, I can then just rename the model that I want to, give it a nice name, recognizable name, right, for the REST API and the OML service. Give it a affinity OML models, and then say that it's shared, and say that okay, right? So now if I click on deployments, you see all of the deployments that are available here. And that includes Oracle Machine Learning in database models, and that will include some Onyx models as well. I'm going to explain that later. But now from this point on, you can see that these models have been deployed. Okay. Now, so how do I score with that model? Right. It was very nice. I built the model using a UI, and I press a button and I deploy the model. But what do I do with the model? So that model goes and it's registered to our Oracle Machine Learning service, which again is available to all autonomous database licenses, including the always free. It is available to anyone with an autonomous database account. And so what that does is that creates that REST API component. So for example, right here on the left-hand side, you see the curl command. That is an example. So what we need to do is, for OML services, you get a token, and then you pass that token. And then as you can see on the animation, I'm saying, give me the top 5 prediction details. These are the input records. I send that request, and then I get my score back. And the score shows me the probabilities that are requested, right? This is scoring results, classification, and I see the column name. So I see the columns that were the attributes, right, that were responsible for that probability of 92% of not buying, right? So basically that's the process here, right? You can see the prediction details and that information. And you can see it took 350 milliseconds, but the usual is probably 100 milliseconds, even lower, depending on the data center, depending on your distance to the data center of your application. So on the left-hand side, again, you normally use your URL. You have a unique URL per data center, right? So depending on the data center, that the Oracle you have, you got to give that URL. And then you have a model URI, right, which is the model name that we defined. And then you have a few settings, including that token that I mentioned before, right? So hopefully that that was interesting for you guys. You can always learn more about this, and I'll show you guys a link for that. But where to go from here in terms of the Oracle Machine Learning, in terms of all the different things that I showed, we have a lot of different links that we offer you guys. So we have all the way from the oracle.com, the main machine learning component. We have a lot of tutorials now. So you can see the machine learning live labs. These are tutorials where we can teach you guys. You spend a couple hours with us, and you can follow the instructions in the tutorial and go by yourself, or you can join one of our sessions as well and follow with the instructor, right? We have an Oracle Machine Learning office hours as well in Ask Tom. I do that every Tuesday. We have many sessions that we do that. I'm going to show you guys a quick list of those sessions. But that's for, if you have questions, if you want to learn more, if you have curiosity of what we're doing with it. And I'm normally inviting people that are working with OML today to join and do a quick demo of things that they are working on, right? So that the audience can actually learn more about it. And then we have specific videos and links to Oracle Machine Learning for Python, AutoML UI, and OML services as well. So we have short videos explaining all the different components and things that you can do. Okay. Then we have, as I mentioned, the sessions, right? So from my previous sessions, if you guys are not very familiar with machine learning, or exactly, when I use classification versus regression, what does that even mean? When to use a decision tree versus a neural network, does that make sense? You guys probably would want to take a look at my machine learning 101 sessions. So I had 101 sessions from all the way since May last year, but I've been doing those, and then beginning of the year, we finished with feature extraction. So all of these sessions are available on that link on the top. And then you can take a look at the new ones, and you can subscribe to the sessions that we have coming up. So as I mentioned, next week I'm having the next one, but you can always see the previous ones, and you can see the recordings. So since May this year, on the left-hand side, we've been doing a lot of these hands-on lab and usage highlight as well. So we've been showing what other Oracle products have been using inside their components, right, on OML, but also hands-on labs on OML services, hands-on lab on AutoML UI. So, spend 2 hours looking at, or an hour and a half looking at that process and exactly how that works. We have links so you can download examples. You can download a PDF with everything that we teach there, right? So I think it's a good way for you guys to learn more if you're interested. And then I would open that for Q&A. If you guys have any specific questions you would like to ask.
Yeah, I was just going to say, Marcos, I looked it up for you. I didn't know the answer for sure either, but on 18C XE, they did have, for the data scientists and machine learning people, the advanced analytics option is available for
Okay,
18C, which means you could use the in-memory
perfect.
feature.
Okay, perfect. So yeah, so if the advanced analytics option is available, then yes, OML is there.
Yeah.
Excellent. Thank you.
We have a question. AutoML builds Python for you. Are they going to build SQL in the future? If you want to
Yes,
do it that way.
exactly. So that's a great question. Yes. So we have that project coming up. It's lined up. I'm not sure if we're going to be able to get it before the end of the year, but we're working on it right now because we know that many of our customers just want to use the facility, right, and build the model with the UI and then press a button and get the PL SQL code out, right? So we have that. We are working on that for sure. Thank you.
That's great.
And
I was
then
gonna, I saw PyCharm, and I was gonna say PyCharm is great too. If people.
Oh yes,
Python
absolutely,
But
absolutely. Yeah, and I see that. Oh yeah, so I see a question about discriminative and generative ML models in OML. So yeah, so the idea is, so you can the types, if you have any type of algorithm, right, that you don't have yet in OML. What normally our customers are doing is that they are taking advantage of the open source versions of algorithms, right? So it will really depend on CPU and RAM available to you, right, for running those things. But we have customers running open source algorithms from Python whenever they cannot find the algorithm that we provide. Now, having said that, in OML today, in Autonomous, we provide scikit-learn, right? We provide NumPy, we provide SciPy. So we have a limited set of things that we can provide as an open source tools. So you could use scikit-learn and build a random forest algorithm, right? You could use scikit-learn to build an not XGBoost, but some other algorithm that you might not like or you might not find in our lineup of algorithms. But you can't upload your own packages, right? In Autonomous, that has been some again, lots of customers asking for it, working on a way to do that. But it's a complicated security, right, issue, as you would imagine. Now, when we launch OML for Pi on premises in DB21 and then backported to 19C, at that point, because that uses XProc components to communicate with Python, then you can actually install anything in Python in that Python session that will let you run other algorithms, right? So maybe for that question in terms of if you're looking for specific types of generative ML models, potentially that's something that you might find more easily, right? Based on that. So as soon as we have that capability, then it potentially is part of that.
And maybe lastly, can you talk about, when you use Oracle, security and speed of Oracle, what are the benefits there? Because there seems to be a lot of them with things like Exadata.
Oh yeah, so I think one of the things that you have to bear in mind, right, is when you think about performance and security, right? Everything that you have with the Oracle database, the full security, the full quality of that security, the full capability of that computation behind the scenes is available for OML, right? So when you build in database algorithms and models, what happens to them is they are available to you. They are smart enough, so we have smart scan. So when you're scoring, especially, you're going to get that benefit that we're not going to score at the compute level. That goes down to the storage level, right, in the Exadata side. So you have all of that capability available to you, all of that power, in addition, right, to all of that security that you already have. So the data never leaves the database, and that's probably one of the most sacred things nowadays, right? Is that you don't pull that data out through JDBC and push it somewhere else. When you're running these algorithms and models and scorings, everything is in there and is locked down, right? So it gives the data scientist that flexibility, but also keeping in check that the quality of that service and then the security, right? We did some benchmarks not long ago. We did some benchmarks. If you guys look for blogs on Oracle, you're going to see the benchmarks that we did on data all the way up to, I think it was 800 million records. We were just looking for how can that scale, right, as well. So it's a beauty because then it scales super well, right, because Exadata is the technology behind the scenes. And then you can go to billions of records without issues running, inside the notebooks, right? So never having to pull the data out. Yeah, that's a great question.
That's great. So with that, I don't see any more questions. So Marcos, I don't know if you have anything else to add.
I think that's it on my side. So I just really appreciate the opportunity and thank you very much, guys. And I'll distribute the PDF, so hopefully you guys can share with the audience, and then looking forward for the next one.
We will do that. Thanks so much, Marcos, and thanks everybody for joining us this week. And we'll have the recording soon and also the slides. Thanks, everyone. Have a great day.
Thank you. I really appreciate it. Bye-bye.